How's it, grade 11s? So we're still busy with reduction. We're working from slides 92 to 98 from the trigonometry PowerPoints. So today is going to be a little bit different with the reduction, as you'll see in a second. So we're going to go straight into an example, and it's example 3. And they're saying here, write each as a ratio of 15 or 70 degrees. So we want either 15 degrees or 70 degrees. Okay, so if we look at example A, we've got sine 290 degrees. Okay, so sine 290 or 290 is in the fourth quadrant. Okay, if I just draw up our cast diagram, we know that sine in the fourth is negative, so this is negative sine. And to reduce that, we say 360 minus that 290, and we get 70. Okay, and we have got it in terms of one of the angles that they wanted, which was 70. Okay, and we leave it just like that. If we look at example B, we've got cos 105 degrees. Okay, now 105 is in the second quadrant. We know that cos in the second is negative, so this will become negative cos. And to reduce that, we say 180 minus 105, and we get 75. Now we've got a bit of a problem because 75 is neither 15 nor 70, okay? But we can be tricky. If I try and now look for co-functions, have a look at this. 75 plus 15 will give us 90. So those are co-functions, so I can swap between those two. And how I do it is we're going to say minus cos, and it's going to be 90 minus 75. Okay, and I'm using my co-function. Now remember, as soon as this 90 appears, we know we're dealing with co-co. All right, so I'm not changing anything in terms of the sign or anything like that because we're still in the first quadrant. 90 minus is in the first quadrant, so this will still remain minus something. But because we're using co-co, cos will change to a sine. Okay, so we now got sine 90 minus 75 is 15. And we've got it in terms of one of the angles that they wanted. Okay, if we look at example C now, we've got sine 435 degrees. Okay, so this is bigger than 360. So you know what we do with this? We subtract 360 from it to try and get an angle between 0 and 360. So 435 minus 360, and we've got an angle in our first quadrant, which is what we wanted. So this is the same as saying sine 75 degrees. Okay, so now we're back at the same step over here, where we have a 75, which is neither 15 nor 70, but 75 and 15 are co-functions. So I'm going to change this. So I'm going to now say sine 90 minus 75. Okay, and as soon as I do that, this is co-co, that sign will change to a cos, and we get cos 90 minus 75 is 15 degrees. Okay, so you can even check that though, grade 11s. If I check sine 75, we're getting root 6 plus root 2 over 4. If I check cos 15, root 6 plus root 2 over 4. They're the same thing, okay? So from this example, I would like you guys to do exercise 7.6, numbers 2, 3, and 4, okay? I'm going to skip example 4 for now, and I'll do that tomorrow. I'm going to go on to example 5 because it's very similar to what this is. Okay, and it's how they're going to ask it in exams and cycles and that sort of thing. Okay, so example 5, we'll come back to example 4 tomorrow. Example 5, they're saying express the following in terms of P if tan 28 degrees is equal to P. Okay, so very similar to example 3, except now we have a whole trig function with it. Okay, so if we look at example A, they're telling us tan 152 degrees. Okay, so 152 is in the second quadrant. We know that tan in the second is negative. And to reduce that 152, we say 180 minus 152, and we get 28. And have a look at that. That's exactly what they've given us. Tan 28. So this tan 28 becomes P. So this answer here is minus P. Okay. If we look at example B, we've got tan 208. Okay. So 208 is in the third quadrant. We know that tan in the third is positive. So this will become tan. And to reduce that, we say 208 minus 180, and we get 28. And then again, we have tan 28, which is they've given to us, is equal to P. So this answer here is equal to P. Okay. Going on to the last example, sine 62 degrees. Okay, now this is going to be a bit of a problem because we don't know anything about 62 degrees. We just know that 28 or tan of 28 is P. Now, if you add 62 to 28, you'll get 90. 62 plus 28, you get 90. So we know that these two angles are complementary. So that is what I'm going to do here. I'm going to say that this is sine 90 minus 62. Okay. As soon as I do that, this is cocoa. So sine will change to a cos. So we get cos 90 minus 68 is 28, minus 62 is 28. Okay, so now I'm happy because I've got a 28 degrees, 28 degrees. We can now work on this trig function, this tan and the cos, okay? Because we don't know what cos 28 is in terms of P. Now, this is where your Pythag comes into play. And we've done questions like this before, where we find the missing value, either x, y, or r. So we know that 28 is in the first quadrant. And that is 28 degrees, and that's 90. Now I'll come back to what they've given us. Now this is over a secret 1. Okay, so tan 28 is equal to P over 1. We also know that tan is y over x. So if I put that onto my drawing now, over here, we know that our y value is P, so our y value is here, and our x value is 1. So what I can do now is I can find my r value. Okay, so we know that r squared is equal to x squared plus y squared, which is Pythag. So r squared is equal to x is 1 squared plus y is p squared. So we get r squared is equal to 1 plus p squared. I take the square root and I get r is equal to the square root of 1 plus p squared. But now remember, grade 11s, when we take the square root, it's plus or minus. But I can't take the minus for r because r is a length. Only your x and your y can be negative or positive. Okay, so cos in terms of x, y, and r is x over r. So what is our x value for this 28 degrees. Our x value is 1 over. What is our r value for this 28? Well, we've just calculated it here. So this is 1 plus p squared in a square root. And we have solved sine 62 in terms of p using what they've given us. Okay, so grade 11s, for this one I would like you to do exercise 7.6, numbers 5 and 6 for me, please. Thank you.